Hello students, this is Jennifer Hawksworth, and this course is Engineering Mechanics Statics. So this course will introduce students to the study of equilibrium of bodies subjected to forces. So I've taken this course and I've broken it into the following chapters. We're going to start with a brief introduction, talk about force vectors, force system resultants, equilibrium of bodies. We'll do a chapter on structural analysis, and then finish up the course with centers of gravity, centroids, and moments of inertia. Statics is usually the first engineering mechanics course that students take for their engineering program at the university level. So we're going to be studying forces and their impacts. And this course is going to help us develop our problem-solving skills because we'll learn to examine how forces and bodies act and react to one another. So the first chapter is an introduction. So these are the sections for the first chapter. We'll go over an introduction to mechanics. We'll discuss some fundamentals, systems of units, significant figures, and then finish this chapter with a method for analysis. So engineers make things happen. They get things done. They design, construct, analyze, and test devices, from simple objects such as can openers and snowboards to more complex ones such as vehicles and bridges. And in order to do this, engineers must know the physics fundamental to their design, and they also must be able to use mathematics to predict the performance of their design. So in this course, we'll begin to develop the ability to analyze a problem in a logical, simple approach by studying statics. So the first chapter is basically an introduction. So we'll cover basic information that we'll use throughout this course. And we'll cover things like definitions, fundamental concepts. We'll review Newton's laws of motion and gravitation. We'll go over systems of units and converting between them. And then at the end, we'll devise a method for analysis. So basically a problem-solving strategy. So 1.1, Introduction to Mechanics. So these are our learning goals for this first section. We basically want to gain an understanding of engineering mechanics and statics, and we want to gain an appreciation of the vastness of the field of engineering. Engineering is the use of scientific and mathematical knowledge to creatively solve practical problems in the real world. And the field of engineering is divided into many areas, so I have some of those listed on the next slide. There's a lot of overlap among the different areas of engineering, and engineers in all these areas need to have a strong understanding of physics and mathematics. So these are just some of the areas of engineering. You have your mechanical engineering, civil, electrical, structural, aerospace, nuclear, biomedical, chemical, computer, environmental, industrial, and there's other ones that I don't even have listed here. So it's a very vast topic. Engineering mechanics is the study of bodies subjected to forces. So it can be thought of as a branch of the physical sciences concerning the conditions of rest or motion of bodies under the action of forces. So it basically describes and predicts physical situations. And it also provides a foundation for engineering applications. So there are three parts to mechanics. You have mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. The mechanics of rigid bodies is then further divided into statics and dynamics. Statics is the study of bodies at rest or moving with a constant velocity. So basically it deals with the equilibrium of bodies, and it's used to determine the forces that are necessary to keep the body in equilibrium. And these forces, they can be either external to the body or they can be within the body. Dynamics, on the other hand, studies bodies in motion. So those bodies can have a constant velocity or they can be accelerating. Dynamics is a separate course from statics. This flowchart will give you a better idea of engineering mechanics, right? This is just one area of engineering. And look how vast this is. So engineering mechanics is broken down into mechanics of solids and the mechanics of fluids. The mechanics of solids is broken down further into rigid bodies and deformable bodies. Rigid bodies is broken down into statics and dynamics. So this is where we are over here, statics. So we're on that branch of the tree. Dynamics can be broken down further. And you can also see how deformable bodies is broken down, how there's two branches to the mechanics of fluids. You have compressible fluids and incompressible fluids. So there's a lot to engineering mechanics, and we're only seeing one small portion of it right now. I'm going to use the term bodies throughout this course, and body refers to an object such as a book, a table, a car, and so on. Bodies subjected to forces can either be at rest or in motion. Rigid bodies. In statics and in dynamics, bodies are assumed to be completely rigid. In actuality, structures and machines are never absolutely rigid, and they do deform under the forces which they are subjected, but it's usually small enough that they don't impact the conditions of equilibrium, and we can kind of just disregard them. So in this course, you can assume that the bodies we're referring to are rigid bodies. I want to make a quick historical note. So the study of mechanics of rigid bodies dates all the way back to the time of Archimedes, but an acceptable formulation of the fundamentals of mechanics wasn't actually articulated until Newton. Now, there are some limitations on Newtonian mechanics, and they were realized when Einstein derived his theory of relativity, but Newtonian mechanics is still the basis of today's engineering sciences.